So someone was asking me in this question, 6.263 of the Calculus Volume 1, how did I get this expression here? So this was my logic. This is what was happening mentally. So the bottom of this pyramid, remember, it's a square-based pyramid. It's definitely 2 and 2. So there's no doubt about that. And then as you move up the pyramid, can you imagine that this shrinks down? So it gets smaller, and it gets smaller, and it gets smaller, and then it gets smaller, and it gets smaller, and it gets smaller, and then it's gone. So you can imagine the square is shrinking. So algebraically, how can we think about that? Well, this length starts off as 2, and then as the x increases, it has to drop to 0, drops down to 0 square. This is as x grows from. And at the beginning, x is 0, so it's as x grows from 0 to 6. So I need an expression that begins at 2 and finishes at 0 when x goes from 0 to 6. So it's a little bit like coordinate geometry. If you want to picture it like this, when x is 0, we have to start off at 2. And then when we get to 6, then the length is dropped to 0. So it's like this is the relationship here. This is x, and then this, if we want to call this a letter L, this is the length here. So when x is 0, the length is 2, but when x is 6, the length is dropped to 0. Now from coordinate geometry, you can get a formula here. If you want, it's y minus y1 equals m times x minus x1. So y is actually L. L minus, and we might as well use this point here. This is the point 0, 2. So L minus 2 equals m. The slope or the gradient is the rise over the run. So that would be negative 2 over 6. X minus 0. So cleaning that up a little bit, let me just put it here. That would be L minus 2 equals minus 2 over 6x. So that is L equals 2 minus 2 over 6x. Or to match it up with more closely with what I have, that's L equals 2 minus 2 x over 6. So that's one length of the square. So the area, which would be L squared, that would be 2 minus 2 x over 6 squared. So that's exactly the same thing as I got here. So basically in my head, more or less, that's what I was doing. I was trying to arrive at an algebraic expression that would represent the area here shrinking from 2 by 2 to 0.